Today at 3:30. Oh, by the way, I'm your moderator. My name is Hannah Tyneson. Nice to see you. And today in this room at 3:30, we have Dimitar, who is currently building a software as a service with UI5 front end and have interest in math and problem solving. What he's going to tell us is extreme freestyle, pushing the limits of reusability and extensibility. So the stage is yours. Yep. Thank you, Dimitar.
Thanks, Hannah, for this introduction. And as mentioned, I'm working as the developer of a product which uses OpenUI5 exclusively as its front-end solution. The goal of this session is to highlight a couple of design practices and patterns that we have discovered during the development of our software. Let's start by providing some context about our technological landscape. It's very important to do so because unlike traditional development scenarios where UI5 is used in conjunction with various other ACP technologies to build a well-defined customer-requested solution, we're using UI5 to build a B2C product. With more than 10,000 developer hours poured into the project, we haven't done any concrete measurements, but it's perhaps one of the biggest non-SAP OpenUI5 projects, if not the biggest one. And this has several big implications. First, we were inclined to pursue more open architecture right from the get-go. Building a product is no easy feat, so we aimed to have a bigger access to community of product builders, so we decided for more open backend. Second, because the use case differs so much, some rules or guidelines, some constraints lose their relevance. For example, the SAP Fiori guidelines, which usually serve to guide and protect developers from pitfalls, now serve much more as advice and generic design guideline rather than strict rule. For example, you might be familiar with the traditional Fiori overview floor plan, and that is a dashboard app. And for comparison, here's how our app looks like. It's an app for management of both personal and company finance, and it allows you to build any dashboard. And just to make the comparison with Fiori, everything here is custom. Those are custom control charts on a custom control dashboard. It's completely custom. Let's take a brief look at a simplified version of our tech stack. Our architecture resides completely in the cloud and consists out of multiple Node.js servers. There are gateways, Kubernetes, stuff around, but the important part here is that the OpenUI5 apps are served statically using essentially the Express static serve. They are pre-bundled and statically served. And this has major front-end implications. Essentially, because of the non-SAP backend, it means that all of our front-end code is Freestyle OpenUI5. We only have access to the open part of it. And this means that furthermore, traditional reuse fostering tools such as ACP Flexibility, the Fiori app library, Fiori elements, we have access to none of that. And this has actually posed the defining challenge of our front-end setup. How, using only OpenUI5, do we foster reusability and maintainability in our front-end setup? How do we reuse code? And can UI5 even be used as competitor to other frameworks in such a way? We decided to tackle this challenge and search for questions to these answers head-on. It turns out that the means to design, scale, and maintain such a system are available today natively. For today's session, I've prepared 5 of the most impactful design practices and patterns that we have discovered and implemented in our system. Unfortunately, due to time constraints, I cannot explore each of them in great detail. This will be more of an overview approach, but still, the patterns as listed here are sorted ascending based on complexity. The first topic I want to talk about is, once again, TypeScript. It's difficult to overstate the impact this has had on our product and developer experience. While TypeScript is good for projects both big and small, this is especially relevant for smaller or startup-ish like teams. thanks to the built-in level of safety that the language provides, we are able to move fast and do breaking changes often. A startup's key metrics, for example, are rapid prototyping and concept evaluation, and TypeScript enables us to do just that. For example, complex cases, for example, we can do breaking changes often, and to expand on this point, complex cases require caution, but the simpler errors that occur when you do a breaking change, TypeScript linter can very easily catch them, because when you break a simpler contract, let's say that's just an interface of a function, you get errors everywhere right away. So from this perspective, it allows us to move very fast. Second, TypeScript itself facilitates a form of work delegation. By this, I mean that thanks to TypeScript, we have the ability to onboard a tiny bit less, because new developers can explore the code base on their own, more easily at least. And additionally, we have the ability to test, I'm going to say it, a tiny bit less. Yeah, sorry for that. But essentially, because TypeScript catches type-related issues at dev time, you don't have to write tests for those. Nevertheless, let's move on. The next concept I wanna talk about focuses on the reusability topic. For clarity, let's suppose a classical dry violation scenario. Suppose you have an app, you have some notepad control inside, which has to now be used in another application. Copying the control source from app to app will only work so far before maintenance becomes a nightmare. And to address this, UI5 has this type of project called library. And by putting our notepad control in one such library, we have essentially eliminated this dry problem. However, this is pretty much where the standard scenario stops. You might add some more controls to the control library, introduce subdirectories, grouping, nesting, even add utility classes to the library. But for us, this was simply not enough. We had to not only reuse custom controls, but full-blown application modules. And in our extreme freestyle scenario, we had no access, as mentioned, to Fiori elements or other such stuff. So we thought, why just not use a library again? And it turns out that libraries are not limited to what type of content they contain. At the end, they are just bundled together with the application, so we are free to put in there anything we like, including more controllers, business logic classes, and even fragments. Importing these assets by namespace works perfectly, and we have actually solved a major issue, because we might have no access to Fiori Launchpad, for example, but we can still achieve consistent layouting in all of our apps. If we put the root layout in a fragment, let's call it the shell fragment, put the fragment in some library, we can just then reference it in every client app just by pulling this fragment from the library. And we have this consistent layouting. Furthermore, if we want to have reusable logic, we can put this, let's say there are a couple of methods that we want to reuse. And we can easily put them in a base controller, put the controller inside a library, and inherit from it in every client app. And this way, we can also achieve functionality reuse. However, this was not enough for us. We decided to push this on. It is well known that inheritance poses constraints on the developer in certain types of designs, where composition would clearly be a better approach. And for this, we decided for once to actually look in the docs. There we found a hidden gem, or perhaps not so hidden, and that gem was the SAP UI Core MVC controller extension class. For those unfamiliar with it, it does exactly what its name says. It extends controllers. And crucially, it does so by composition. For example, now we can achieve the exact same effect of functionality reuse, but this time we put our methods in one such controller extension. And then we can reference multiple controller extensions in our controllers, and we essentially have achieved the same effect, but this time without polluting the prototype chain of our controller. Pushing on, we decided to put all of our controller extensions in libraries. And this was a bit of a magical moment for us, because with all these reusable controller extensions in the libraries, our applications now could be built dynamically because you have these reusable logic chunks that you just compose together on the fly. And every application is just built using these blocks. We can take a brief look at how this looks like, and that's the classical composition demo. We just pull two extensions, reference them in the controller, and we have achieved this mixture of functionality without extending anything and without writing code twice. At Sproutsoft, we have adopted this approach dogmatically. Almost all new functionality that has reuse potential goes inside the library. And yeah, this helps very much with reusability. The next topic I have prepared is a big one, so I will start from the definition. Modular architecture for us means structuring our applications and libraries using a consistent and functionality-centered approach. Every piece of code, every class, function, or UI asset belongs to some logical group which we call a module. An archetype of module might look like the following. We have multiple service layer classes, and if the module interacts with the UI, then we also add a controller extension. The service layer classes have various non-overlapping responsibilities, and yeah, if we want to interact with the UI, add event handlers, we can put this stuff inside one controller extension. Let's take a look at an example and consider the following invoice module. In a typical scenario, the application will have network requests, event handlers, model prompts, and more. And since we already defined the logical grouping, and that's invoice, we can split our code as follows. We can have an HTTP service layer class, and we put all of our network requests inside. We can also have a utility service layer class for any functionality that's not essentially a formatter, but still useful in some way. We also have the model service for dealing with prompts, confirmations, warnings, etc. And crucially, we have the invoice service TS, and that's the main service class. It exposes methods which actually the controller extensions, event handlers, invoke. This is the most important class in the module, and it contains pure business logic, as there are no UI interactions there. And as it contains pure logic, it can actually even be made framework agnostic. What does this mean? Well, it's a service layer class, and if it only depends on other service layer classes, then it actually has no UI5 dependencies, and thus can operate in any context or framework. The invoice extension.ts, that's just the controller extension of the module. We put there anything, any event handlers or UI interaction that we'd like. We enable the module, or rather the event handlers of the controller extension, by simply referencing it in some controller. And as the service layer is prohibited from interacting with the UI, we interact with UI5 APIs mostly from here. Nevertheless, this is just an example. Oftentimes you might find out that you don't need most of these classes. And therefore, the minimal edge case of a module consists only out of a single service layer class or out of a single controller extension. By applying this modular approach to the whole front end, the system is well structured and clean. And furthermore, because functionality is now well scoped, in practice we found out that change requests, changes, are too often scoped to single modules. For example, a new change request comes only for the invoice module, only it is affected and changed in Git. Furthermore, we encourage module reuse and extensibility. This means that we can put these modules inside the libraries and then extend them in client applications, and this works perfect too. Let's move on. The next concept that I want to talk about is the one of state management. The issue of state management is fundamental to front-end web development. However, despite its importance, there hasn't been a definitive answer to the how question. Furthermore, existing guides do not take into account the addition of TypeScript. And so should some NPM library be used? Can we avoid the pain of merging strings? And how does TypeScript help? To answer these questions, we have developed a custom UI5 library available on GitHub called UI5 state. And I cannot go into detail of its features, but nevertheless, we can still do a quick feature tour. At its core, there is the state service class, which is an adapter or wrapper for the JSON model. We pass in our data, our type, and define setters. And thanks to TypeScript, the state service then exposes a deep read-only reference to our data. This way, we have achieved fully type-safe read access, while accidental writes are impossible because of this deep read-only reference that we have. Furthermore, as this JSON model reference is internal to the adapter, only the adapter has access to it. This means that for any write operations against the model, we actually have to define appropriate methods. And by doing so, we have effectively eliminated the possibility to do a partial write. For example, suppose you have some complex update operation that consists out of 5 separate statements. If this is done inline every time, you just run the risk of forgetting one of the statements. And with streamlined write access, this is impossible. You just define them at a single place. The final, another great feature that I want to mention is that this library forces you to think about references. While nowhere near as sophisticated as in, say, Rust, you still cannot pass a deep read-only object to a function which accepts a mutable one. You have to either cast it or create a deep copy. But in any way, the developer is forced to make a conscious choice about this. And I personally really love this because the bugs caused by shared by mistake references are pretty tricky to catch. I have to move on, but I think we can still show a quick usage sample. We define our type, let's say that's the type of our module, and we just pass it into the state service. We create a concrete class that extends the base abstract one. We pass in our type, we define some setters, and data is passed in at instantiation, but before that we just have this simple concrete class that allows us streamlined write access with fully typed read access. Let's move on. The final pattern that I have prepared is perhaps the most important one. So far, we saw a couple of different scenarios which require instances of ES classes. For example, the service layer classes, the state service of the module, and having so many ES instances just floating around can be difficult to manage correctly. Without going into detail, I'm just going to say that we took a look at different solutions, but at the end concluded that dependency injection is perhaps the best way to go. However, the implementation was no easy feat. After a quick search, we found no UI5 examples of usage of DI, so we had to turn to other frameworks for inspiration. For example, in React, if you even do DI, you often do it using some NPM library. But we found that none of these libraries are actually pretty convenient or suitable for use in UI5. In Angular and Nest.js, this is actually the standard way of importing stuff. You don't have SAP UI define, SAP UI require. You just mark the constructor params, and dependency injection resolves instances for you at runtime. And we actually run Nest.js on our backend node servers, so we were familiar with the functionality already. And we thought, why just not take a shot at implementing it ourselves? The result was UI5 DI. This is another library available on GitHub and NPM, and it has simple interface, many features, but we can only do a quick feature tour. Let's suppose the following utility service layer class. We can simply annotate it using injectable. If you want to import this class, then we don't have to manually deal with instantiation ourselves. We can simply reference it as constructor parameter in our business service layer class. And the dependency injection library will automatically resolve the instances for us. This works because behind the scenes, both classes are annotated using this injectable decorator. So they are added to some internal DI registry. But there's a caveat. The sharp eye will notice that these are indeed ES classes. And UI5 itself uses AMD ones. So how do they communicate? And the library actually solves this. Because it is built especially for UI5, we have exposed this settle function, which essentially grants you access to the DI registry. At any AMD class, at any place in your code, you can just hook in to the DI system using settle and pull an instance this way. Unfortunately, this is all I have prepared for today. I want to thank you for the attention. And yeah, you can find links here to the relevant.
Thank you very much, Dimitar. Now is Q&A time. Any questions here?
Okay.
Oh, there. Here first.
Hi. It's a great example of certainly pushing UI5 to the limits for non-SAP. A couple of questions. You mentioned this was a SaaS application. Was it built as like a typical multi-tenant SaaS application, or are you deploying it separately for each customer? That's the first question.
It's definitely multi-tenant. We have a single deployment, single database for all of our customers.
Okay. And what kind of framework did you use for the multi-tenancy?
On the backend, we run Nest.js. Essentially, the backend, everything is completely in the cloud. There is a single deployment. And there are multiple servers running together. One of them serves the file statically. And on the backend, the API, everything is handled by a Nest.js custom-built API. Behind that, we have a database where all of our customers' data is stored.
Okay. And how do you do the separation of the tenants in that case? I guess I'm interested from the perspective of if, for example, we have the CAP framework, which has multi-tenancy built in and it's out of the box. So if you do it all from scratch, I was just interested in the
I guess it's actually more like a single tenant because everything is stored in a single database. We don't deploy multiple databases or divide the customers in any other way. They're stored on the same place.
Okay. And the second question, as I said, great example of pushing UI5 to the limits. Typically with SaaS, non-SAP SaaS applications, companies use other frameworks and other platforms. So after your experience, what would you say are the benefits of going the UI5 route, and why didn't you choose the other typical platforms that other SaaS companies use?
This one we get a lot. And actually there are a great deal of benefits and a single disadvantage. The benefits are many, and namely you get so many stuff out of the box just working. You don't have to deal with library hell. We don't have to argue what library for state management are we going to use, what flavor of CSS we want to use. All of these functionalities already work and are pre-packaged. You have theming, localization, state management, controls. All of these features just come out of the box working with minimal setup. And all of this just speaks in favor of UI5.
Thank you.
Yeah.
Perfect. I think there is another question in the back.
Yeah, thank you for a great presentation. As mentioned, did you think about using CAP as instead for the middle layer, so you actually would have OData delivered to the front end and couldn't convert?
Actually, this was a question that we asked ourselves, but the timing was just not right. By the time CAP came out as a stable and pushed solution, we were already on our way. We had already made some decisions, and we didn't want to go back on those. But if we had to start today, perhaps definitely, why not?
Oh, there's one last question in the back.
How did you deal with authentication when you're not in the SAP ecosystem?
As mentioned, we wanted an open backend because open backend means greater access to community of product builders. And this is a very common problem to solve when you build a product. There are, for example, third-party solutions such as Auth0 or something from AWS, Cognito, for example. But what we did was we took the Express library, Passport, and we have just adapted it to interact with our database accordingly. It's session-based, so to speak.
Thank you very much, Dimitar. I'm pretty sure there are still many questions here. So feel free to reach out to Dimitar later on in the networking area and find him and ask all these questions. So thank you so much.
Thank you.
Coming up next,